Hey there, this video is going to go over the difference of squares and how we can factor them. I'm going to show two different ways. First, what I think is important is that we understand where difference of squares come from. So in general, what we're looking for as a formula is that we have a squared minus b squared, and what we're going to be able to factor it into is two separate factors, one being a minus b and the other one being a plus b. Starting with a large square, we're going to have a large square with dimensions of a by a. So the length and width are both equal to each other and they both are going to be labeled with a. What I need to subtract off is a smaller square, and I'm going to label it with side length of b. So this is going to be a b by b square. So length and width are both equal to b, and what we're going to do is subtract this off. So we have a large square and then we're subtracting off a smaller square. The question is what is left over and how can we express that? So what we're really doing with the difference of squares is we're taking away the area of two different squares and seeing what's left over. To figure out what's left over, I'm going to break this square into two pieces. First, the rectangle on the right has a dimension. We already know that the length of it is going to be a. And what we need to do is figure out what would the width be. Well, the full length across this square is a. This side here is b. So to figure out what would be left over, this would just be a minus b. For the smaller rectangle on the left here we already have this dimension because it's labeled above. This is side length b. To figure out this side length, it's very similar to what we just did. The entire side length is equal to a. This side here is b. So then what we can do is subtract them from each other, and that's going to give us our expression here, and that would be a minus b. So how do we figure out the rest of the area? Well, the area of this is going to be equal to the rectangle on the right side, which as an area would be length times width. So the length is a, and we're timesing by the width, which is a minus b. What I need to add to that is the rectangle on the left. So for the area of that, we would have b for the length and the width of a minus b. What we notice is that when it comes to factoring, I can factor out anything that terms have in common. So these terms have a minus b both being in common, which means that I can factor it out. So the area left over, I'm going to factor out a minus b from both of these terms. When I factor it out of the first term, a times a minus b divided by a minus b just leaves me with a. When I factor it out of the second term, what I'm going to be left with is positive b. Because b times a minus b divided by a minus b just leaves me with b. And what we notice is we get this formula here. So what we're essentially saying is that how do we now go from the left side to the right side? Let's look at a few examples. So here are a few examples of difference of squares. I'm going to show a few different ways of how we can look at factoring them. So the first one is going to be starting from the model that we did on the other page. So we're starting with a squared minus b squared is equal to a minus b times a plus b. What we want to look at is what are the relationships between the left side and the right side and how do we get there. What I notice is that my a squared turns into a and a. What I notice about b squared is that it turns into b and b. So how do I get from a squared to a? Or how do I get from b squared to b? What I have to do is I have to undo the squaring part, which is square rooting. So here's what I'm going to do. I'm going to rewrite what I have above underneath. I have x squared minus 16. So if we were to rewrite this, or if we think about how do I get from a or x squared minus 16 into the two factors, we again can look at our formula. So how do we get from a squared to a? Well, we square rooted. Well, let's square root x squared. The square root of x squared is just x. Then what we know now is our a value. We know the number that should be beginning both of these factors. Next, I'm going to look at 16. What is the square root of 16? Well, that is 4. What I should notice here is that in my formula, one of these factors is subtraction and one of these factors is addition. The order that this happens in doesn't really matter as long as one is negative and one is positive. So what we'll have here is minus 4 and plus 4. And now you have the factored form of this polynomial. The other way of doing this question is thinking back to trinomial factoring. I could rewrite this expression as follows. X squared plus 0x minus 16. Now this looks like a trinomial, and you may have been shown that you can factor a trinomial by finding two numbers that multiply to the product of the first number and the last number. So 1 times negative 16 is negative 16. Those same two numbers have to add to the middle value, which in this case is 0. So the two numbers that are going to be working here is negative 4 and positive 4. Negative 4 and positive 4 will also add to 0. Here I can go straight to my factors because I have a trinomial where the a value is 1. So my first factor would be x minus 4, coming from this set of numbers, and my other one would be x plus 4, which is coming from those numbers. So those are two different ways of solving that difference of squares. Let's try one more example. Personally, when I do difference of squares, I prefer my first method just because I like square rooting. It just takes, for me, it's just a little bit less time. So when I look at 4x squared, this is no different than what we just did. What we need to do is take the square root of both the first term and the second term. So let's take the square root of 4x squared. What we get is 2x. The square root of 9 is equal to 3. What I need to do is create the two factors, so the a minus b and the a plus b. Well, this is essentially my new a value, and this is essentially my new b value. So I just need to plug them into two factors. My first factor will be 2x minus 3. My second factor would be 2x plus 3. What I like about this method is that when you go into harder examples like what we have here on the right, it makes it a lot more easy because, again, all you're doing is square rooting. So let's try that example out. First, let's take the square root of the first term. When I take the square root, I'm going to get 5, and the square root of x to the power of 4 is x to the power of 2. Remember, what you're trying to do when you're square rooting is you're trying to find two things that when you multiply it together gets you back to the original. So 5 times 5 would give you 25, and x squared times x squared would give you x to the power of 4. Next, let's take the square root of the last term. So the square root of 49 is 7, and the square root of y squared is y. So again, here's my new a value, and here is my new b value. And now we're just plugging it into the factors. My first factor will then be 5x squared minus 7y, 5x squared plus 7y. A question that I get quite often is, can I switch the orders of these? And the answer to that is yes. You could also write this as 5x squared plus 7 and 5x squared plus 7y and then minus 7y. And those two answers are the exact same thing. So it doesn't matter which factor comes first as long as one's negative and one is positive. I hope this video helps you with factoring the difference of squares. Let me know if you have any questions.